Namaste to all of you. My name is Sonal Katyal and you are watching India Science. I hope you had a lazy yet beautiful start of your Sunday morning. Today we are here to add some more fun to your weekend because today it is about some cool crafts. You all must have heard about origami and making those beautiful swans and butterflies from paper. But guess what? We can also learn some cool maths while making these designs. And to tell us how, we have with us today Mr. VSS Sastry, who is a maths and science communicator and has employed mediums like cartoons, sketching, puppetry, modeling, and toys to popularize these subjects. He's amazing with his origami skills and has conducted over 850 workshops on maths through origami. And what's more, he also holds the Limca Book of Records in origami back in 2012. Welcome to India Science, sir. The screen is all yours, and
Yeah,
we are all ready with our A4 size papers and Sunday morning excitement.
very good. So, good morning. I am VSS Sastry. I am from Kolar. I am an origamian and also a mathematician. So, what I have combined is I have combined origami holds to tell mathematics. So, origami, as you know, is the Japanese word. Ori is to hold and kami is paper. So, it is actually holding paper. So, in fact, I had told you, to be prepared with the papers in A4 size papers, like this, and also on a scale, and also, some kind of a writing pen. These things are absolutely necessary, to go for it. Okay, let us start. So, what is meant by origami? I have just told you. So, origami is just, holding paper. So, holding paper is a kind of an art practiced in Japan. In fact, in India, since 100 years, it has already become a folklore. Nobody teaches a child in a primary school, it is not in the curriculum how to make a boat. But every child, in India, knows about it, how to make a boat. So let us start some kind of a serious mathematics, with the boat itself. So this is not only, a kind of a exercise which connects, mathematics, serious mathematics, into this paper holding. And it also shows you the possibilities of a paper holding. We explore very many concepts, which we consider as difficult in a classroom situation. So let us start, with a theorem, proving a theorem, in mathematics. Then let us go for some kind of a geometrical construction, in mathematics. Let us end up with one making a platonic solid, with the paper, in mathematics. And in the between, let us also explore how an ordinary paper holding reveals, something, phenomenal in the mathematics. Like, y 2 to the power of 0 is equal to 1. So let us start. So for a start, you should have a paper like this. This is A4 size paper. So this is A4 size paper. So you should have, this. And let us hold, this A4 size paper, now. So let us see what can be done. You are able to see the paper? Yeah. So this is the paper I have spread out. I will spread out the paper, like this. Okay. So let us take, this one edge of the paper and then, fold it like this. So this is the what, you get. Here is a right angle triangle and here is some extra paper. Here is some extra paper. So this extra paper, we shall hold it like this. So it looks like this. So let us open it and cut this off. So what we have done is this extra paper we have cut it off. So this becomes a square. And this is an extra paper. So this will be useful for the next experiment. Don't throw it away. Keep it aside. So this is the square paper, what we have. So in this square paper, so we shall hold this square paper into half. What we are making is a boat. So half of the paper, is here with us. Next, again, fold it in half. So this is what, you get. So turn it over, like this. Here you will get 4 leaves, 1, 2, 3, and 4. Take, the first leaf up and hold it, towards you. So it will be like this. What we have done is we have taken this paper, this first of all fold. So this, we have put it, like this. Now there are 3. 1, 2, and 3. Hold it back. What we get, is this. So on one side, there are 3 flaps. On the other side, there is 1 flap. But in the middle, there is a pocket. You can see that pocket, here. So this pocket, just, open it like this. Put your finger inside. Open it like this. So it creases itself into a small square like this. This small square has 2 flaps. This one flap and this another flap. And also it has got a crease, like this. A kind of a cleavage, appears. So put it down. Hold this triangle up and crease it like this. It will be like this. So this flap, hold it backwards. So it looks like this. Again, put this up, turn it over, put this up. Again, there are 2 flaps here. Make it ulta. Hold it here, draw it out. So it becomes a boat. This is the boat which every child in India, does. So nobody teaches, as I told you, in the curriculum. It is not in any kind of a lesson, mathematics lesson or a craft lesson. But everybody does it. Everybody, plays with it. So, Madam Ji, can you just, share, that boat, there?
Sure, sir. I'll just share
Yeah,
that.
please. Now we are showing you a sequence of the drawings, which, we have already made. If you are still, get confused, look at those drawings and then, do it. I will wait for about 5 seconds. There are exactly 8 steps. And this is what, the drawing shows. A step-by-step thing, first start from a square, then half of it, then, half of it. Then you get, 4 leaves. So first leaf, down under. Next, what you get is the 3 leaves, up. Put it back. Hold it back. Then in the middle, you get a pocket. Put your fingers there. Then press it down. You get a square. So hold, that A and D, apart. You will get a boat. Okay, let them see, madam.
Yeah, I think. Okay, I'll bring it down now.
Yeah. So this is the boat, what you see. So this boat is this boat, what you see. Now there are various creases, are visible. Various creases are visible. Here also, various creases are visible. How does this boat, has, it does look? In fact, in this figure, we are familiar with, is a trapezium. So the boat is actually opened up trapezium. It has also got a triangle inside. So that apart, we see lot of triangles. Here one triangle, here another, here another one here, another one here, another one here. So totally one, two, three, four, five, six triangles are visible, here. They are all right angle triangles. JV, six triangles are visible. Okay, this is the mathematical description of a boat. It looks like it is actually a trapezium. So it contains, now what we have made. Six triangles, here. Six triangles, here. So let us open it and see. So go back. This is what you did. Make it full time. Put your fingers. So this is what you have done. Three flaps, here. One flap, in the front. This is the square. Open it. Yeah, this is the kind of a creases, you find. You are able to see the creases. So now what we shall do, all these creases here, we shall make it into lines because we cannot see, properly those creases. So I will take a pen. And mark all those lines. All those lines, which are here. These are the lines, you see. So what you have made is a boat. These are the lines, creases, which happen, in a boat. So these creases are all, converge into right angle triangles. There are so many lines, here. I have not added any extra line. So all these are the creases we obtained when we made a normal boat. So let us see. What can be done, with this. All, what we have is are the right angle triangles. ये सारे लंबकोण त्रिकोण है ना, वो देख लीजिएगा. So now when I will take, consider this right angle triangle, here. So let us see. This right angle triangle I will take. I will call it as P, Q, and also this M. See, you can also write, these things. This is E, Q, that is the hypotenuse of right angle triangle. And M is the right angle, where, we have right angle M. Now, Pythagoras theorem, is the one which comes to mind in a right angle triangle PMQ, where M is the right angle and PQ is the hypotenuse. PM and MQ are the sides. So, what does the Pythagoras relationship, say? It says PQ square is equal to PM square plus MQ square. This is what it says, relationship. The square on the hypotenuse is equal to the square on the other two sides. Here the hypotenuse is PQ, that's why it is PQ square, which is equal to the side PM square plus MQ square. So what exactly you mean by PM square and also MQ square? So what we mean is the square standing upon the side EM and also the square standing upon MQ. This is what we mean. Now, let us see, how, Pythagoras relationship, stands out, here. So, on PM, on PM, on PM, we are having, this square. This contains exactly, two right angle triangles, one and two. Two right angle triangles. On side MQ, it also contains a square. It contains these two right angle triangles. That is 3 and 4. So together what we have is 1, 2, 3, 4 right angle triangles on PM square and also MQ square. So look here on PQ. There is also a square which contains 1, 2, 3, 4 right angle triangles. So that means to say what? That means to say what? PQ square contains, four right angle triangles. 1, 2, 3, 4. And the other two sides, PM square contains, two right angle triangles, 1 and 2. And MQ square contains other two right angle triangles, 3 and 4. Totally, PM square plus MQ square is equal to 4 right angle triangles, which is in fact on PQ. That is 1, 2, 3, 4. Is not, the Pythagoras theorem, proved here. So this is my method. I will make an origami model like a boat. Let us make a boat, with this. This is the first hold. This is the second hold. So एक लिफाफा डाउन, लिफाफे जो हैं उसको पीछे डालें और यहाँ पॉकेट जो होता है उसको प्रेस करें और ये उल्टा करें और बन गई बोट. That means to say, with the simple boat, what we have here, we can definitely prove the Pythagoras theorem, Pythagoras relationship. And I hope you people, have enjoyed it. So there are also limitations, with this. For example, this particular relationship, what I have shown you, here, is not a scaling triangle, but it is a right angle isosceles triangle. So that means to say, whether it is possible for a scaling triangle to do. Yes, it is possible. But the time constraint, is there. That's why I'm not showing you Pythagoras relationship in this board, a scaling triangle. Okay, now I hope you have enjoyed it. Please share, this kind of a origami and mathematics in which Pythagoras theorem is proved through a board to your friends. Now, while making a square, with this, ये तो बची है ना, right, in a A4 size paper, this, we got. So let us see, what can be done, with this. So I told you, origami is only, paper folding. Paper holding means that, we just go on, holding the paper in whatever way we want. So now look at here. This is a rectangular shape of paper. It's a small paper, rectangular shape of paper. The entire origami means, holding paper. So here what we have is a rectangular shape paper. So what happens, in this rectangular paper when we hold it, like this? That means I am bringing the opposite edges, together. This is the one hold what we have. So what happens with this one hold? When we open it up, you see a kind of a crease here, a straight line here. And something else also happens. This area is equal to this area. That means it is divided equally into two portions. So go with one hold. Hold is 1. That's what we have. Its divisions, what we got is 2. So let us continue this process. Let us hold, for the second time. So what we have done is we have holded for the second time. So when we unhold it again, what we see are 4 divisions. 1, 2, 3, and 4. 4 divisions, we have got. That means for the second time we have folded the paper, we got 4 divisions. 1, 2, 3, and 4. So let us try again. Let us fold it, for the third time. So fold it like this. It doesn't matter whether you hold it horizontally or vertically. You are holding it for the third time. Open it and see how many divisions. 1, 2, 3, 4, 5, 6, 7, and 8. So for the third division, for the third time when we hold, to get this 8 divisions. Like this shall we continue. So for that, एक बही बनाना होगी because it doesn't stay in our brain. So let us take a piece of paper and make a table. एक बही. So let us keep it aside. Let us take a paper and put it like this. So number of times folded. कितने बार हम मोड़े हैं. Number of divisions got. कितने डिविजन्स हुए हैं. पहले हम क्या किए. First fold we made, we got 2 divisions. Second time we folded, we got 4 divisions. Third time we folded, we got 8 divisions. So fourth time when we do folded, अगर और एक बार आप मोड़ते हैं तो आपको 16 डिविजन मिलेगी. Like this, we can go on holding it. I have a question to you. What happens when I want to hold it, 100 times? 100 times. ये देख लीजिए. So when you hold it one time, you get 2 divisions. When you hold it second time, you get 4 divisions. When you hold it 3 times, you get 8 divisions. When you hold like this 4 times, you get 16 divisions. So if the process you will continue and hold it for 100 times, how many divisions you are going to get? So but paper is very small. So we cannot go on holding 100 times. That is the first objection. But what is not possible, in paper, we can do it, in mathematics. That is what mathematics is all about. That's why we like mathematics. This small paper cannot be folded, 100 times. But in mathematics, we can just, see the relationship and find out if at all this paper is folded 100 times, how many divisions we are going to get. For that, we have to see this pattern. So, look at this pattern. Mathematics is full of patterns. In fact, we can talk about mathematics a little bit here. So, what is exactly mathematics? What does it contains? Mathematics contains full of patterns. So, what do you meant by a pattern? It is all 1, 2, 3, 4. It is all like this 2, 4, 8, 16, etc., etc. First of all, you observe all these are even numbers. Then all these are multiples of 2. Let us write multiples of 2. So it is 2. It is 2 into 2. It is 2 into 2 into 2. It is 2 into 2 into 2 into 2. This is what it is. These are all multiples of 2. Look at the patterns here. Well, if it is, first hold, if it is, first hold, here, you are having, 2, one time. If it is, second hold, you are having 2 into 2, 2 times. If it is, third hold, you are having, 2 into 2 into 2, 3 times. If it is, fourth hold, you are having, 2 into 2 into 2, 4 times. So like this, there is a pattern. So number of times you multiply, number of times you multiply 1 time, 2 hold, number of 1 time, 2 time, 3 time, 4 time you hold. You also have to multiply one time, two times, three times, four times. So definitely no. For 100 times, how many times you have to do? 100 times, you have to do. That means 2 into 2 into 2 into etc. 100 times. This is what you have to do. So now it comes to mathematics again. So we have to use here the mathematical language. There is a mathematical language, to write this. That is called indices, mathematics of indices. So using that, the same thing, we can write like this. It is 2 to the power of 1, 2 to the power of 2. It is 2 to the power of 3, 2 to the power of 4. Like this, we can write. So that means, so these are all, the mathematical language. What I have written is mathematical language. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Definitely, if it is 100 times, it is 2 to the power of 100. Now, we have arrived at the result itself. That means to say it is 2 to the power of 100. So, when we talk about that, so if it is 100 times, here, it is definitely 2 to the power of 100. In mathematics, there is a third characteristic. First characteristic I told you, there is a pattern. Second characteristic I told you, there is some kind of a mathematical language, mathematical symbolism or mathematical language. The third characteristic, is everything, we generalize. What do you mean by generalization? We say if it is 100, we don't say. If it is n times, what happens? That means to say if it is n times, so it is definitely to the power of n. So this is what we have come to. See here, so it is 2 to the power of n. How we got it? We generalized this 1, 2, 3, 4, 100, etc. Generalize it, if it is for n times, how much it will be. So we have arrived at this formula 2 to the power of n, not by any kind of a mathematical induction, just by holding a small piece of paper, like this. We have come to this conclusion. We have arrived at a formula. We have arrived at this formula by holding a paper n times, like this. We arrived at this formula 2 to the power of n. So generalization, it has great advantages in mathematics. If it is a 2 to the power of n, if it is n times, you have folded, it is 2 to the power of n. That means if n is 100, you saw n is 2 to the power of 100. If n is 101, then it is 2 to the power of 101. If it n is 1 lakh, then it is 2 to the power of 1 lakh. That means say as we go forward, n we can just go on increasing and the formula does not change. So how we say that we did not fold here 100 times, but we are sure that is exactly 2 to the power of 100 pieces, 100 divisions. So if it is n, it is exactly 2 to the power of n. This is another characteristic of mathematics, that accuracy. Any formula is accurate, whatever be the value of n. That's why mathematics is very, very useful tool, because once we arrive at a formula, we can extend that formula forward. So there is another characteristic of mathematics which we can take the advantage of. So what we can do is we can just as we going forward, we can just come back. We can come back. Let us say it is 2 to the power of n. It is 2 to the power of 100. It is 2 to the power of 4. It is 2 to the power of 3. 2 to the power of 2. 2 to the power of 1. Let us say, what about 2 to the power of 0? So that means say what? So look to your paper again. This is the 2 to the power of 0. One time we hold it 2 to the power of 1. We got 2 divisions. Two times, we hold it. We got, four divisions. 1, 2, 3, 4. We did not hold anything. That is meant by 2 to the power of 0. That means to say 2 to the power of 0 means how many divisions we got? We got only one division. That's why 2 to the power of 0 is equal to 1. See, my dear friends, by doing one small activity like this, we have proved 2 to the power of 0 equal to 1 through mathematical activity. So remember this classroom situation. Remember the classroom situation. In classroom situation, how we prove 2 to the power of 0 equal to 1? We take x to the power of m, x to the power of n. Divide x to the power of m by x to the power of n. Then we make m is equal to n. Then comes that 2 to the power of 0 equal to 1. So all this kind of a procedure is avoided just to illustrate on a small piece of paper like this, go on holding it and make out a kind of a bahi, understand what is the characteristic of mathematics, and then arrive at one beautiful thing that when we did not hold this paper at all, it was only one piece. It was only one piece. That's why when we are arrived at the 2 to the power of n, a formula for n times holding, when we put n equal to 0, it is 2 to the power of 0. So practically in sense, this paper had only one division when we did not hold at all. This is the meaning of 2 to the power of 0 equal to 1. How did you enjoy it? So this is the technique of origami. We employ paper, holding of the paper, etc. So to illustrate the mathematics, which is difficult to understand in our classroom situation. This also illustrates you how I use the paper in a different ways to illustrate the various things in curriculum mathematics. I have already illustrated you a particular theorem, that is Pythagoras theorem. I am now I have illustrated you how I use paper to put the power of 0 is equal to 1. So like this, even -1 into -1 equal to +1 we proved. That is for another time. Now let us say what about geometrical construction. So let us go for it. I recommend take another A4 size paper like this. Take A4 size paper like this. So we shall go for it. I will just put it down. This is that A4 size paper. So I am making a square. So I will hold a right angle triangle like this. This is the right angle triangle. This is an extra paper. So I will hold that extra paper like this. I will cut this portion off. This is not required now. So we are having only this one. This is the square paper. So hold this square paper into half. So what you get here is this horizontal line. This horizontal line you are getting. So this corner, right hand corner, you bring it along with the left hand corner to this spot. It should touch the line. This is important. This corner should touch the line here. It is touching the line here. This is important. So when you keep it like this is the folded paper. This is the another paper that we are having it. In fact, this can be folded like this, one upon the other. So it looks looks like this. Turn it over. Fold it in half. Turn it in half. Can you recognize this model? In fact, children do it, use it, as a rocket. In fact, you can see on the screen, take 5 seconds, to do it. I will just, wait. So this exactly, has only, 5 steps. So please share the screen, madam. Yes. Take a square paper, make the diagonals, if you want. Okay. Then, fold it in half. Then bring that, that A, B, C, D. I have just put it there. Bring B, bring A, towards that middle. Then you get that. And hold it in half. Again, that half. What you see, is this a rocket. Please show this rocket, madam. Yeah. This is the rocket, which the children also, play, like this rocket. But this can also be, made into a bird. I will show that, later. But for once, it is like this. So as usual, let us open it. You get, lots and lots of, lines here emanating, from one corner, like this. So as usual, we shall put the lines, over all this. So it looks like this. So I will call it as a D. So this is C, this is B, this is A, and it looks like a geometrical construction. So let us give the names E, F, G, H, and I. See, it looks like a geometrical construction. Okay, let me show the model. Okay, let me show the model, madam. Yeah, it's exactly the same. What you say, just to say saw it on the screen. It is exactly the same. So all this kind of it looks like a geometrical construction, but what we have done is only a kind of a rocket. What we have done is only a kind of a rocket. So let us see, what kind of a mathematics, is inside. You see, various lines, emanating from D, like this, DE, DH, DG, DF, DE, etc., etc., etc. So it creates, lots of angles, here, and also it creates lots of angles, here, 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 and here. So let us see what kind of angles, are these. So angle E, angle F, angle G, angle H, and angle I. So these angles, we want. How to find, these angles? We should not use, any protractor. So, but we know, very many things. For example, this is a square. This particular angle is 90 degrees. When it is half, it is 45 degrees. So definitely, this angle is 45 degrees. So this angle is 45 degrees. Why? Because we can do it like this. This angle, whole angle is 90. Half of it is definitely, 45. So this angle is 45 degrees. So like this angle is also 90. It is now divided into 1, 2, 3, 4, 5, 6 divisions. They are all equal divisions. That's why each angle 90 divided by 6 is 15. So this is 15, 15, 15, 15, 15, and 15. So let us write it. This is 15. So this is 15. So this angle is here is 45. This angle is 15. Then what about this angle? You see this is a triangle. Angle D, this E, and C is a triangle. So these are internal angles, 45 degrees as well as 15 degrees are the internal angles. So sum of the internal angles are is equal to the external angle, that E. So this angle E is equal to 15 plus 45, that is 60. So we have arrived at this particular angle 60 using this property that the external angle of a triangle is equal to sum of opposite internal angles 45 plus 15. So what about this angle? Because this is also divided into 6 equal parts, this angle is also 15. So this is 15 plus this is 60 is equal to this angle F, that is 75 degrees. This is 75 degrees. So again, this angle, again, is 15. This is 75. So angle G is 75 plus 15, that is 90. So again, this angle in this particular angle is 15. So this is 90. So angle H is 105. And next angle is 120. So we have here a series of angles, 45 degrees, 60 degrees, 75 degrees, 90 degrees, 105 degrees, 120 degrees, all without using any protractor. So all this, we got how? Only by paper folding. That means to say, we folded the paper like this, we folded, and 50%, we folded, this became a rocket. So I told you, this rocket itself can be made into a bird. It will turn like this. So this one is up. Show my screen, madam. I am doing a bird. So this one is up. Open it like this. Hold it backwards. Hold it again. This is up. This is the beak. Hold it back. Hold it down. This is the bird. So this bird, we made from that rocket. The rocket holding itself, we can make, a kind of a bird. So by making, a bird, like this, inside that, you find all these kind of angles as well as, something more. Example here, there are various types of triangles. You find equilateral triangle, isosceles triangle, obtuse angle triangle, acute angle triangle, etc., etc. So more than 14 kinds of different particular aspects of mathematics can be shown, here. So all, with the paper holding, it makes a kind of a geometrical construction. So like this. It is a bird. So I have shown you three activities by now. By holding a boat, Pythagoras theorem, I have proved it. By holding a small piece of paper many times, I have proved 2 to the power of 0 equal to 1. And by making a bird like this, a rocket or a bird, I have proved how to get in various angles, a kind of a paper protractor, I can say, and as well as various types of triangles. Every type of triangle, we can just see this bird. Is obtuse angle triangle, acute angle triangle, right angle triangle, isosceles right angle triangle, equilateral triangle, etc., etc. In fact, in one count, 14 different concepts, mathematical concepts, we can just go on explaining, in this part. Will not the children, like it? Definitely they do, isn't it? Okay, the last item of the day is making a solid. All these are, just two-dimensional. So, how about doing a three-dimensional solid? We shall make one. We shall make a tetrahedron. Tetrahedron, as you know, is a platonic solid. So there are 5 types of platonic solids, and tetrahedron is the first one. In ordinary language, we call it as triangular pyramid. So for this, we require 2 A4 size papers. So let us take it. So these are the 2 A4 size papers, we have. In fact, both the papers, are folded, similarly. So I will hold, for your convenience, both the papers, not together, one after the other. So I'll keep this away. This is an A4 size paper. A4 size paper. Fold it in half. What you get here is a kind of a crease like this. Straight line. Go to this corner, the right hand corner, and hold it as you have done previously, this line. Look here, this is important. This corner should come and sit on this line here, on this line. So now you have already folded it. This edge, bring it here to the slant edge. You get this. When you look at it, you get a triangle like this. This is a tile, and let us make it ulta. You can see it better. This is an equilateral triangle with a tile. So this tile, we shall lift it up, put it like this. Put it inside. Inside means lift the paper up and hold it inside. Now it is an equilateral triangle. Beautiful equilateral triangle. So let us make it ulta. So what you get is this. Here you get a line. Here is kind of a broken portion. Here this corner is complete. So here there is a line. Observe that there is a line here. So along this line, just fold it down. Along this line. So now you get 2 right-angle triangles. So 2 equilateral triangles. So hold this equilateral triangle like this. And this is a broken triangle. This is not complete. So do it like this. This is again a equilateral triangle with 1, 2, 3, and in the center 4 equilateral triangles. There are 4 equilateral triangles here. So this is the kind of a construction what we are making in other A4 size paper also. Remember this broken triangle. So this we shall hold it like this, make a crease. So this is the model we want. So we shall put it aside. Take this paper, another paper. We are going to do the same model. Please watch if you have missed, the earlier one. First, we shall hold it like this. First crease, open it. You get a line like this. Take the right hand corner, bring it to the line. This is important as I told you. This line, this corner should touch, this line. This is important. Then this edge, bring it to the slant edge. You get, this shape. So here there is a tile. So make it ulta. Now you can see this is an equilateral triangle with a tile. Tile is folded up. This is folded inside. Lift it up and put it inside. Now it is an equilateral triangle. So make it ulta. Here there is a broken portion. Here there is a line. Observe this. Here there is no line, but this is not a broken portion. This line, here, this line, hold along that line down, touch, this edge. So here is an equilateral triangle, here is an equilateral triangle. Hold it up. This again, hold it like this. What we are having is this. This is one equilateral triangle, second equilateral triangle, third equilateral triangle. In the center there is four. I told you there is a broken triangle here. It is not complete. So fold this here like this. Crease. So you get, like this. These are the two models. Here the strange thing is there is a pocket here. There is also another pocket, here. Another pocket here. There are two pockets, for this. So we shall put, these two into these pockets. Now you see this tetrahedron is complete. Tetrahedron is triangular pyramid. Everywhere there are triangles. 1, 2, 3, bottom is 4. This is the tetrahedron. So now you have seen how to make, a kind of a solid. So it looks like a samosa, isn't it? Samosa itself is tetrahedron, a triangular pyramid. This is one of the 5 solids, called, Euler solids or platonic solids. So this has got a beautiful mathematical relationship between, these characteristics. What are the characteristics, here? It has got a face. This is a triangular face. It has got, the vertex. 1, 2, 3, and 4 vertices. It has got, edges. So between this vertex, this edge, and face, there is the relationship that is called as. Okay, let us see, how we can just, see that. For example, how many vertices are there? B, that is vertex 1, 2, 3, and 4. 4 vertices are there. How many faces are there? 1, 2, 3, bottom 4. 4 faces are there. How many edges are there? This is one edge, second edge, third edge, fourth, fifth, and this is sixth. So Euler, said that E plus V is equal to F plus 2. Number of faces, number of vertices is equal to number of edges plus 2. So that's how, the mathematics is involved even in this solid. I have shown you, today only, 4 examples how paper, can be used, mathematics can be used to origami. it can be realized. All these are useful in classroom situations. It does not require much of the expense. It is not a kind of a teaching aid. It is actually a learning aid because students, each can have a paper in their hands, do the things, and see the mathematics, inside. Holding a paper, making a boat, making a bird, or a rocket, or a solid, samosa like this is very easy as well as interesting for the students. Once you teach them how to make a boat or a bird or this tetrahedron, they will go on making it in their spare time because it is a play. So each time they do it, they will also see the mathematics inside. This is the trick I employ in mathematics through origami. So thank you very much, and I hope you people have enjoyed it. If there are any kind of a questions, I will just take.
Thank you so much, sir. This was such a great session. We all might have made a paper boat in our childhood or the plane, but who wondered that there is so much maths hidden in it. Thank you so much for making origami double fun for us. I would also like to thank all our viewers who joined us today. Thank you so much. And VS Shastri ji has also done a session with us where he introduced some cool mathematical toys. It is available on our OTT channel, which is www.indiascience.in. You can catch all these videos, more fun science videos, on our mobile app as well, which is available on Google and Apple Play stores. Till then, thank you so much again, and keep learning, keep watching. Namaste.
Namaskar.